The next sequence is an equals to -1 to power n divided by 2 times square root of n. So to find the limit of this sequence, first let us find the limit of the absolute value. First, we find the limit of the absolute value of this sequence. Why is that? Because we had a nice theorem. If the limit of absolute value of an as n goes to infinity is equal to 0, then you can conclude that the limit of an is equal to 0 as well. So this is the theorem of our focus. So if you take a look at the limit of the absolute value, it's basically finding the limit of the absolute value of -1 to power x divided by 2 times square root of x as x goes to infinity, which in turn is equal to the limit of 1 divided by absolute value of 2 times square root of x as x goes to infinity. 1 divided by infinity is equal to 0. So what's the meaning of that? The limit of absolute value of an is equal to 0. So for sure, you can conclude that the limit of an is 0 as well. So this is our conclusion. Since the limit of an, absolute value of an as n goes to infinity is equal to 0, then we can conclude that the limit of an as n goes to infinity is equal to 0 as well. So the sequence converges to 0. So that's our conclusion using the theorem that we introduced in class. Another sequence. Consider an to be equal to -1 to power n plus 1 times n divided by n plus square root of n. What is the behavior of this sequence? To find the limit of this sequence, we're going to apply the same theorem. If you can show that the limit of absolute value of an is equal to 0, then you can conclude that the limit of an is equal to 0 as well. So let me copy this guy down here, paste. But what is the limit of absolute value of an? To find the limit of absolute value of an, you're basically finding the limit of -1 to power x plus 1 times x divided by x plus square root of x as x goes to infinity. This indeed is equal to the limit of absolute value of x divided by absolute value of x plus square root of x as x goes to infinity. So to find this limit, let's divide everything by x. This is equal to the limit of absolute value of x divided by x over the absolute value of x over x plus square root of x over x as x goes to infinity. Now let us simplify as much as we can. This is equal to the limit of absolute value of 1, which is 1, divided by absolute value of 1, plus, if you simplify this, you get 1 over square root of x as x goes to infinity. Well, this guy indeed is equal to 0. So you end up with the limit of constant function 1 or just 1. So what happens here? The limit of absolute value is 1. Can we say that the sequence itself converges or not? You can also look at this way. When you look at the degree of the numerator is equal to 1. The degree of the denominator is also equals to 1. So if you find the limit this way, what does it tell us? Does it tell us that the limit is equal to 1? It doesn't. Because if you have negative values, if you have positive values, you get different values. It says, hey, the absolute value is equal to 1. Please pay attention. When we are talking about the theorem here, the theorem says if it is equal to 0, then you can conclude that the limit of the sequence itself is equal to 0. But when we look at the absolute value, it is equal to 1. So this theorem doesn't give us the guarantee that the limit of this sequence itself is equal to 1. So it's a common mistake for students that they work with the absolute value and they say, hey, since the absolute value is equal to 1, the limit of an is equal to 1. It is not true. What we can do here, instead of applying the theorem, since the theorem doesn't work, the theorem doesn't work here. So what should we do? We can divide up the sequence into two portions. One portion is when n is equal to even, and the other portion is when is equal to odd. So take a look at your sequence. When n is equal to an even value, -1 to power n plus 1 becomes negative. So you end up with negative n divided by n plus square root of n. When n is odd, you have n over n plus square root of n. Then you can take the limit of each one of these separately. The limit of -n divided by n plus square root of n as n goes to infinity can be written as the limit of -n over n divided by n over n plus square root of n over n. N goes to infinity. This limit is equal to the limit of 1 divided by 1 plus 1 over square root of n as n goes to infinity. This is just 0, so you end up with 1. But when n is equal to odd, what do we have here? I forgot to put negative sign. But n is equal to odd value, you have the limit of n over n plus square root of n as n goes to infinity, which can be written as the limit of n over n divided by n over n plus square root of n over n as n goes to infinity. So you end up with the limit of 1 divided by 1 plus 1 over square root of n as n goes to infinity. This is just 0, so you end up with 1. Since these two numbers are not equal to each other, since these numbers are not equal, so the sequence is not convergent. Okay, let me rewrite this, re-explain this for you.